Good evening, everyone, and thanks for being here today. And my name is Xinyu Zhou, and I'm very excited to have to share my topic about AutoMQ and the newest feature of AutoMQ table topic. And I will show how to use AutoMQ to bridge the gap between the streaming and analytics with Apache Iceberg. So before that, I would like to introduce myself. And I'm the co-founder and CTO of AutoMQ, and before founding AutoMQ, I worked for Alibaba Cloud for about 7 years, and where I was responsible for some messaging and streaming products in Alibaba Cloud. And I'm very active in open source community, especially in Apache community, and I'm one of the member of Apache Foundation and the PMC member of AutoMQ and incubator. And also I'm mentoring a new Apache project named Apache Omoro, which is a lakehouse management system for data lake. And so let's begin. Okay, today I will introduce my topic in 4 parts. First is about AutoMQ and the evolution of the streaming world. And the second, let's deep dive into the architecture of AutoMQ and its advantages. And then I will show the new feature table topic and show how to integrate AutoMQ with Apache Iceberg and along with the AWS latest product, AWS S3 tables, and which was launched at this year's reunion. And finally, I will show a demo to demonstrate how to use AutoMQ and along with the AWS S3 tables and Iceberg. Yeah. So let's go to the first part. Basically, AutoMQ is a new project, and it's a cloud native alternative to Apache Kafka. And we have replaced the Intel storage layer of Apache Kafka to cloud storage like UBS and S3. And also AutoMQ is a source available project, and you can clone it and start on GitHub. And currently we have nearly 4,000 stargazers worldwide, and over 40 core contributors from different companies like AutoMQ, Zhou, Trademarks, Jingdong, and so on. So welcome to join us, and any contributions are welcome. Okay, let's back to have a look at the evolution of the streaming world, which is evolved more than 10 years. Yeah, okay, Apache Kafka is beginning since 2011, and it has been open sourced by LinkedIn, and its excellent performance and the classic shard architecture have resolved the scalability issue in on-premise environment. And so finally, it has been adopted by a large number of companies, and it gradually became the de facto of the stream storage. So after that, the commercial opportunity started to emerge. So there are 2 big Kafka vendors, Confluent and Redpanda, are leading the technical innovations. And the biggest technical innovations of Confluent are the K-Raft and the tier storage. K-Raft makes the Kafka architecture cleaner, and while the tier storage can reduce the storage costs. And Redpanda has rewritten the Apache Kafka through native language C++, and uses the Raft replication protocol instead of the SR. So leading to further improvements in performance. But basically, both Confluent and Redpanda are based on shared nothing architecture and with tier storage optimization. So there are regards to the architecture, there are no big differences between Confluent and Redpanda. And today, cloud native technologies are reshaping the infra software in the realm of stream storage. There are 2 companies have emerged, like WebStream and AutoMQ. And both have successfully implemented cloud native Kafka and achieved an impressive tenfold reduction in costs. And the WebStream architecture is very clean and is built on direct on S3. And but it has two issues. The first one is the latency issue. In each write to there are more than 1 second end-to-end latency of WebStream. And another concern is about the compatibility. Yeah, upstream have rewritten the Apache Kafka from the scratch, so it's really a challenge, and so there are many Kafka APIs are not supported by upstream, and AutoMQ and also store the entire data on audio storage. But we have a different architecture, and by decoupling the storage and computation, and we offload the storage to EBS and S3, and it's a truly shared storage architecture, and also we don't have the latency and the compatible issue. Yeah. So let's deep dive into the architecture of AutoMQ and its advantages. Yeah. The biggest innovation of AutoMQ lies in the storage layer. Yeah. And we have developed a stream storage library called S3 Stream, which combines the EBS and the S3 storage. Yeah. And there is no replication because the cloud storage also ensure the durability. EBS has multiple replicas, and the S3 has erasure code to provide more than 12 lines durability. So there is no replication. And so you may wonder that why we need two kinds of cloud storage, EBS and S3, and that's because there is no one single type of cloud storage can meet the demands of stream storage. As the stream storage requires no latency and low cost and high throughput. And although the S3 almost meets all the requirements, but it has high latency. Yeah, it's not optimized for high IOPS scenarios. Yeah. And so EBS offers sub-millisecond latency, but its space is very expensive. So we use EBS as a wall storage and S3 as a data storage. For each broker, we only need 10 GB EBS volume. The cost is negligible. So now we have S3 stream, and then we replaced the Kafka storage layer with S3 stream, and we transferred the architecture of Apache Kafka from shared NAS architecture to shared storage architecture, and eventually it became stateless. So we can deploy AutoMQ cluster just like a stateless service. Microservice is very easy, and we even can employ the support instances. Yeah. And then we can automate everything to achieve an elastic architecture. We show a matrix collector to collect the key metrics from the Intel cluster, and so now we have two automated controllers. Yeah, the first is the auto scaling controller, and it watches the loads of the Intel cluster and makes decisions to scale in or scale out the cluster in response to the workload, the load. Yeah. And we have auto balancing controller and the tool which can minimize the hot spotting by dynamically reassigning partitions over the Intel cluster. So you may wonder that why AutoMQ can claim its architecture is cloud native. And that's because we designed AutoMQ for the cloud, and we have leveraged many cloud native technologies to design AutoMQ, like we use the durability of cloud storage, and even we use a multi-touch feature of EBS for failover and the elasticity of APIs to provision resources like EC2. And even we can use support instances to deploy a stateful storage system again. So that's why we claim our architecture is cloud native. Yeah. Okay, you will find the core components of AutoMQ is the S3 stream. So let's explore it in more details here. And in S3 stream, data from a producer is written to wall storage persistently and then uploaded to object storage in nearly real time. Yeah. And the consumers can read data from the S3, and of course there is a memory cache for the acceleration, so the turning rate consumers no need to access the data without the object storage. Yeah. And what's more, the S3 stream consists of a shared wall storage and object storage. And the important that is that the wall storage can have many implementations. It's very flexible to compensate the differences between in the cloud storage abilities among various cloud providers. Almost all of the cloud providers offers EBS storage, so we can use EBS as a wall storage. And some of cloud providers like Azure, GCP, and Alibaba Cloud even offer regional EBS. So we can mix it. It's a good idea to use regional EBS as a wall storage. So even if you have a high performance alternative to S3, like you deployed a MIO cluster on high performance SSD devices, or your business is latency relaxed, you even can use S3 storage as a wall storage. So that means the architecture of AutoMQ also supported build on S3 directly, just like WebStream. So it's about the architecture of AutoMQ. And so then I would like to share the advantages of AutoMQ, and the most important one is the cost. AutoMQ can reduce the 90% of the cost of both for the storage and compute. And for storage, AutoMQ replaces the three replicas EBS volume with a single replica of the storage. So which is 20x cheaper. Yeah. For compute, because AutoMQ is an elastic and serverless architecture, so it can prevent over provisioning, and even we can use support instances, so we can achieve a 19% reduction in computer costs. Yeah. And what's more, AutoMQ's shared storage architecture greatly enhances the operational efficiency. Yeah, like for partition reassignment, AutoMQ can reassign a partition in seconds. That's because there is no data replication involved, but it can take up to several hours for Apache Kafka. Yeah, when it comes to the cluster scaling, and AutoMQ can balance the traffic of new loads over the entire cluster in seconds by reassigning partitions in batches. But it can take up to days for Apache Kafka. And the third one is about the compatibility, and AutoMQ is fully compatibility with Apache Kafka. Actually, we have replaced the storage layer of Apache Kafka, but we kept all the code from the computation layer. That means all the features like compile topic, identify producer, and transactional messages also are supported by AutoMQ. And in fact, we have replaced the storage layer through a very small log segment aspect. So it's easy for AutoMQ to synchronize the code from the Apache Kafka upstream. So in the future, AutoMQ can very easy can support the new feature very easily. Obviously, it's a big challenge for many Kafka vendors. Yeah. So this is the big advantages of AutoMQ. Okay, let's go to the third part. I would like to introduce the table topic and how to integrate with S3 tables and Apache Iceberg. Yeah. Before that, I want to share a vision about the data architecture. And we can observe that there is a trend that all the data-intensive software will eventually store the data on object storage. Yes. But even though all the data is stored on object storage, but there is no simple way to share the data between different systems. The ETLs, the data format conversions are needed here. Yes. So we recently from the shared storage architecture to shared data architecture is the next critical evolution of data technology. Yeah. So the table solution like Iceberg have unified the table format in data lake. So we think Iceberg can make this happen, make the shared data architecture happens. Yeah. So we have imagined that the shared data architecture of AutoMQ and the data is the data is generated in a streaming manner and stored in log storage. So the Flink jobs, the Spark jobs, and the Kafka consumers can mine the real-time values of the data in stream APIs. But after the data is loses its freshness, the table topic feature can convert the log data to the table data. So that means that all the technology of big data can access this data through a zero ETL approach. So there is no need to replicate data between different systems. So this is why we would like to develop the table topic feature. So let's have an in-depth look at the table topic architecture. It's a built-in feature in AutoMQ, and basically it's a new type of it's a new type of topic. Yeah, it's a hybrid with stream topic and table. Yeah. So there are three parts of the table topic. The first part is about the schema and catalog management. And we support a built-in Kafka schema registry and support automatic schema evolution. And also we currently support AWS Glue and Table Bucket as a catalog service. And in the future, we will also support the rest catalog service here. And the core component of table topic is the table coordinator. Okay, each topic has a table coordinator and always run with a partition 0. And which is responsible for centralized coordination for Iceberg snapshot submissions and to reduce the commit frequency and avoid performance conflicts. And the next is the table workers. Yeah, each AutoMQ broker has an embedded table worker and with Iceberg writer and is responsible for writing all the data from the streaming to the table. And also, all the partitions in current broker will share the same table worker to reduce the CPU and the memory usage. Yes. And the table workers will handle the data uploads by listening to the commit request events, which is emitted by the table coordinator through or inner control topic. So this is the architecture of table topic. So let me share the benefits of AutoMQ table topic. And firstly, it's very easy to set up. Yeah, you only need to, when you are creating a topic, you only need to single click to enable this feature, and there is no extra configurations, no Flink jobs, and no Kafka Connect. And also we support built-in schema registry, and we AutoMQ has an out-of-the-box Kafka schema registry and support auto creation of Iceberg tables and schema evolution. Yeah. And the most important benefits is a zero ETL. We can eliminate the traditional ETL pipelines, and which can reduce the cost and the operational complexity significantly. And next is the auto scaling. And we both know that AutoMQ is a serverless architecture, elastic, yeah, right. And so table topic is a built-in feature. So the table topic can leverage the auto scaling and auto balancing controllers to balance the load between the table workers. So it's an auto scaling feature. And finally, AutoMQ table topic can seamlessly integrate with AWS S3 tables, the latest AWS product, and we can utilize the S3 tables high performance and integrate the catalog. And the most important is the table maintenance. So we don't need to worry about the table and the data compaction and snapshot management. The S3 tables will handle these jobs. And also, AutoMQ table topic can seamlessly integrate with the AWS analytics products such as Asana, EMR, Redshift, and QuickSight, and so on. Yeah. So let's go to the final part. And I would like to share a demo to show how to use the AutoMQ table topic. So first, you should subscribe to the AutoMQ, and AutoMQ provide run your own cloud model, also named the BYOC product on the AWS marketplace. So just that means you can install the entire AutoMQ cluster into your own AWS account and VPCs. So the first step is subscribing the AutoMQ and install the AutoMQ control plane into your own account. Then you will get a URL of the AutoMQ console and with an initial password. So after logging into the AutoMQ VLC console, and you can create an AutoMQ instance with table topic enabled. But before that, you should visit the AWS S3 console to create a new type bucket, a table bucket, and record its ARN and associate it with the AutoMQ instance. And then you can create a test topic and with table topic feature enabled, just one click to enable the table topic when you are creating a test topic. Yeah. So after creating a table topic, now we can prepare some data. And this demo we have select a clickstream schema which has many columns like event ID, event name, event time, event type, and then we prepare some data and send this data via Kafka Avro console producer and send this data to the table topic. Okay, after sending the data, we can query the table data from the AWS Athena. It's very easy. So we can just use the simplest SQL to select all the data from the AWS Athena, and you will get the result in just seconds. Yeah. So this is a very simple example to show how AutoMQ and AutoMQ table topic integrate with AWS S3 tables and Apache Iceberg. So that's all about my presentation. And if you want to further communicate with me, and you can connect me on LinkedIn. And okay, thank you.